Welcome to lesson 7144, simple harmonic motion. Okay, so we're going to need these two equations here. Distance equals A times sine omega t, or distance equals A cosine omega t, and then you can read the rest. Frequency is omega over 2 pi, so this is Greek letter omega here. Oscillation means the thing is going back and forth. Okay, here is the picture of the diagram. So we have a radius of 8. Something moves in a circular fashion for 3.45 seconds. It covers a distance of 8 pi t. And we have our x-coordinate at x cosine 8 pi t. So now, what is the frequency of the piston? The frequency is the x value divided by the period. So 8 pi divided by 2 pi equals 4 strokes or cycles per second. Cycles per second. And let's look at B. What is the distance from the starting point? So now we're going to stick in d of 0. And we know the cosine at 0 is 1, so 8 times 1 is just 8. And then the d at 3.45 is equal to 8 cosine 8 pi times 3.45 seconds, which is going to be about 2.47 seconds. And then 8 at 0 minus 2.47, the distance it got to, and at a time, is about 5.53 centimeters, because that's our distance, centimeters. So the piston is that far away in 3.45 seconds from its rest. Okay, so let's look at what we have. We have the 5 centimeters is the bottom of our spring, and the mass is suspended from them. We pull the spring down. The spring is usually at rest at 0 centimeters, and I didn't draw that too well. I probably should move that 0 up, or I'll move the mass down. So let's move the mass down to, so the first picture, A, is at rest. B is pulled down to 5 centimeters extension or below rest. And C, the mass snaps up to a fully compressed position on a spring. And this is harmonic motion, something oscillating up and down. Okay, since the mass is going up and down, we're going to use D equals A sine omega t. We know the amplitude is equal to the maximum height, which is 5, away from the midline. It takes 2 seconds. The period is 2. The frequency is the inverse of the period, which equals 1 over 2. So omega over 2 pi. 2 pi is the period of the sine wave, equals 1 over 2. And a little cross multiplication, W is equal to pi. So, putting it all together, D equals the amplitude, sine pi t. That's our modeling equation.